Hi, I'm Priyanka from Intel. In this video, we go over the model optimizer, which is a model converter included in the OpenVINO Toolkit. We cover how it converts models and discuss important optimization techniques that are used during conversion. First off, let's discuss deep learning application deployment. With the traditional methods, you take pre-trained deep learning model as input to the computer vision application and infer each input frame from the video or image. The application deployment slightly changes with the OpenVINO Toolkit as you need to do one-time pre-trained model conversion using Model Optimizer. Then you pass the intermediate representation files to the Inference Engine to infer input frames. So keeping this slight change in mind, let's go into more details of the Model Optimizer functionality. Model Optimizer is a cross-platform command line tool that takes pre-trained deep learning models from frameworks such as Caffe, TensorFlow or MXNet and optimizes them for performance and space using conservative topology transformations. It performs static model analysis and adjusts deep learning models for optimal execution on endpoint target devices. Model Optimizer is written in Python and supports a wide range of deep learning topologies such as AlexNet, GoogleNet, ResNet, SSDs. Now let's look at the techniques used by Model Optimizer for model conversion. It takes the input model topology graph and during conversion it uses techniques such as horizontal fusing, dropping unused layers, fold shift with convolution in addition to many others. It also supports quantization to convert from FP32 to FP16. Default quantization is FP32. Model Optimizer fuses different layers of the topology graphs to reduce the number of function calls. When you look at the import model topology and the converted model topology, you can see that some of the layers are fused. For example, fusing a ReLU layer with the convolutional layer is relatively easy as it has only one if statement. This process inlines the code where you are fusing operations and avoids overloading additional layers. This leads to better performance without changing any mathematics in the code or making any logical code changes in the model. Now I'm going to show you how to use Model Optimizer with some input parameters you can set. For this example, we will show you how to convert a Caffe model. First, we will need to run mo_caffe.py file from the Model Optimizer folder. Let's run the command with help option. You can see that Model Optimizer takes many parameters such as input model, output location, floating point quantization, mean or scale values. Run the Model Optimizer to convert the public SqueezeNet Caffe model for the classification sample. I'm running mo_caffe.python file with the input as squeezenet.caffe model file and output directory as my home folder. At the end of the execution of Model Optimizer command, it shows the IR files that are generated with the XML and bin extension. You can see these files in the output directory. The Caffe model file gets converted to XML file and the proto-text file gets converted to bin file. The default quantization for Model Optimizer is FP32. However, you can change that with the data type flag to FP16. The Caffe model isn't the only supported framework for Model Optimizer. You can also convert TensorFlow and MXNet models to intermediate formats to be used by the Inference Engine. Thanks for watching. The next video in this series will cover how to use these intermediate representation models from the Model Optimizer with the Inference Engine in order to deploy application on different platforms.
Hey, I hope you liked this video. If you haven't seen our other videos on the Intel Software YouTube channel, remember to subscribe and don't forget to leave us a comment and tell us what other material you might like to see and chat with other enthusiasts who watch our shows.